Uh, yes, so sorry. This is the part of before the previous one. I have already recorded. I have started the recordings that was got disconnected. So in this one, I am starting from the last point. So before that, please watch the uh, program part three. So first watch the program part three, then watch this one, program part four. Okay, so what I was saying, if we divide the 153 by 10, then number will become 15. So here again, file loop will continue. 15 is greater than 0. And here it will, if we divide 53 by 10, then remainder will be, sorry, 15 by 10, the remainder will be 5. So here 5 to the power 3 we are calculating, and that we are adding with 27. Again, we are dividing the number by 10. So 15 divided by 10 is 1. So 1 will be assigned here. 1 is greater than 0. And if we try to find the modulus, that will be 1, right? So we are 1 to the power 3 that we will add. And again, we will get the final value, final summation of all of this one. And here we will divide 1 by 10. So that will give 0. So here this condition will become false. So while loop will stop executing. So we got this one in this variable sum. Now we will compare if both are equal or not. If both are equal, then number is arm. If both are not equal, then number is not arm. Okay. So now if I run this, okay, so the number is arm, it is showing. So that is, it is correct. If I give 154, so a 154 is not an Armstrong number. So if I run this, so it should give us the result as not arm. So it is giving us not arm. Okay, so this is the logic. So actually in this program, we have covered one more program to find the total number of digits of a number. So this also we have done, and this is the logic for to find the Armstrong number. Okay. Now the next thing is sum of digits. In this number, there are we have to calculate the sum of the digits. That means 1 plus 5 plus 3. So it will be 9. So it will be the logic will be same as the Armstrong number that we have discussed. Only thing is that we will not do the uh, we will not find any cube of any number. We will simply add it. Okay, so I will start with sum equal to 0, and same logic. Here I will divide it by 10, so I will get the remainder. That remainder I will add with the sum. So if we divide 153, the remainder will be 3. So 3 I will add as, so it will be 3. Then I will divide the number by 10. The number will become 15. 15 is greater than 0. So 15 modulus 10 will be 5. So here we will add. So the sum is 3 and last is 5. So it will be 8. Now I will divide number by 10. So number will become 1. 1 is greater than 0. 1 modulus will be 1. 1 plus 8 equal to 9. A number will be divided by 10, so it will be 0. Now the condition will become false, and the sum is 9, so it will print 9. So in this way, we have to calculate the number of sum of all the digits of a number. It is showing us 9. Only thing is this one, modulus and division. These two things you have to keep in mind. while dealing with digits of a number, sum of all the digits of a number, Armstrong of a number. This is important thing which you have to remember. Okay, now the next one is to print prime number from 1 to 100. So how to find prime number, that logic I have already explained in the second part of the program video. So please watch that one first. Then you will be able to understand the logic first to find the Armstrong number, as to find uh, the prime number. So that logic I am not explaining again. So it is very clear, like 2 is from 1 to 100, the first prime number is 2 and the next prime number is 3. So 2 and 3 is fixed. So here I have taken n2 as 2 and n3 as 3, and that number I am printing. 2 space 3 space. So first two prime number I have printed. Now since two number is already printed, so I will from 1 to 100 till 3 it is printed. So I will start a for loop where I will start from 4, because till 3 we have already printed, and it will go to 100. Now within this I have written the logic to find the prime number. It will calculate the prime number. Here the main logic is, here f is, if f is equal to 0, then that number is a prime number. In any case f becomes 1, then that is not a prime number. Okay, so based on that, if you watch the prime number, how to find a prime number, in the second part of the recording, the second part of the video, program video, then you will understand its logic. Then you will be able to understand how it is calculated. So now if I run this, it is printing the number, all the prime numbers from 1 to 100. Okay. Now the next one is to find the factorial of a number. You know, like how to find the factorial. If I give you any number, so from that number till 1, you have to multiply. Let's suppose the number is 5, then 5 into 4 into 3 into 2 into 1. If number is 10, then 10 into 9 into 8 into 7 into 6 into 5. In this way, it will go to 1. So this is how we calculate the factorial of a number. So here integer f equal to 5. This one we have to calculate factorial of this number. In order to get the result, I have taken an integer variable and its starting value is 1. Now here what I am doing, in the result I am adding f. So initially the value of f is 5. So 5 into 1 is 5. And now here I am decrementing the number by 1. So here f becomes 4. 4 is greater than 0. Now this is 5. 5 into 4, 20. Now f has become 3. 3 is greater than 0. 20 into 3, 60. F becomes 2. 2 is greater than 0. 60 into 2, 120. Sorry. F has become 1. 1 is greater than 0. 120 into 1 is 120. F has become 0. 0 is greater than 0. False. So we get result as 120. So this is how we calculate the factorial of a number. It's very simple. If you see Armstrong number, sum of the digits, and the factorial, all are same. Almost, or I will not say same, but it's almost similar. So see, it is showing 120. So this is how we calculate factorial of a number. Now the next one, to find any random number, I will give you a range, and within that range you have to generate any random number. Okay, so the minimum range is 200 and maximum range is 400. And there is a by default formula. First of all, there is a by default method called math.random. This method generates a random number in the form of decimal. In the form of decimal number, it generates a random number. And there is a formula to calculate any random number between a minimum range to maximum range. So this is the formula that you have to remember. Okay. Give this formula and it will give you any random number between these two range in the form of decimal, because this math.random return type is double, and double is an decimal number. It represents a decimal number. Okay, so by default it will return a decimal number between 200 to 400. If you want an integer number, so here you have to typecast it. So first of all, it will generate a random decimal number between 200 to 400 that I'm printing here. In the next one, what I'm doing, same thing, but this one I'm typecasting to integer and storing an integer variable. So now this one will give me any integer number, any random integer number between 200 to 400. Okay, now if you run this, so see it is giving a random number 340 pointing to this, and in the decimal it is giving this one as the random number. Now if I run again, see now it is giving a different random number. So this math.random is responsible for generating any random number between 200 to 400, and this is the entire formula. This will generate any random number, but if you want to generate a random number between a range, then you have to multiply this with this one, this formula. And here you have to define minimum and maximum range. Based on that, it will calculate the value. Okay. Math.random will generate any random number between 0 to 1. The range will be 0 to 1 only in the form of decimal. But if you want to generate a random number between a range, so first of all, you have to define the range, and this you have to multiply with this formula. This formula you have to remember. Okay. Then it will generate a random number between these two numbers, between this range. Okay. So we have covered everything, and one more pattern. So before that, in my last three program recording, I have covered the three pattern program, and this is the fourth one I'm covering, and this will be the last. Apart from that, there are many patterns, but all the patterns will be almost similar to these four patterns that I'm explaining. So if you know how to crack these four patterns, the logic, if you understand, you can crack logic for any other pattern. So that is very simple. Okay, so here in this one, the pattern which I'm generating is this one. First, this is the first part of the pattern. Like in every row, for the in first row it will generate one number, in the second row it will generate two number, in the third row it will generate three number, in the fourth row it will generate four number. So whenever the row is incrementing, value will also incrementing. So the row and value is same. Okay, but here the way the number is generating is it will always starts with 1, and it will go to 2. In the second row it will go to 2, third row 3, fourth row 4, fifth row 5, sixth row 6, seventh row 7. So this is the first part of this pattern. This you have to crack. So the total number of row is 7. So first for loop I have started with row for row. Now second for loop I'm starting to print this number. Okay. And you know, like here the maximum limit will be I, because in every row, based on the number of row, the value is printing, and the row is represented by I. So here it will be I. But I will print J, because here J is always starting from 1, and it will go till the value of I. So the first time the value of I is 1, so it will only print 1. Next time the value of I will be 2, so it will print 1 and 2. Third time the value of I will be 3, so it will print 1, 2, and 3. So here you have to print the value of J so that it will print in this. So this is the first part of the program. Now the second part. And the second part you see here the decrementing. Here number is getting decremented by 1. And the total number of row is 6, as you can see. So that is why, since this is a decrementing part, so here I have written the logic for decrementing. The value of I will start from 6, and one by one it will keep on decrementing. That means 6, 5, 4, 3, 2, and 1. Okay, and we will print the value of J. Here it will go till I. So currently the value of I is 6. So it will print 1 to 6. Because j will start from 1, so it will go till from 1 to 6. Now the next value of I will be 5, so it will print from 1 to 5. Then next value will be 4, then it will print from 1 to 4. Here, one by one, the value of I is decrementing. So in this way, it will print number from in this. This is the second part of the program, and it's very easy, as you can see. It's not very tough. Now if you run this, so it will print the same pattern. Okay, so this is the fourth pattern, and this is the last pattern program which I'm explaining. Apart from that, you can practice. There are so many patterns, but all will be almost similar to each other, and the way of cracking the logic will be same, which I have explained in this video and in the previous video also. Okay. So thank you everyone.